Hello and welcome to my class. In this video, I will be showing you how to obtain the expectation of a random variable if the random variable is binomially distributed with parameters n being the number of trials and p being the probability of success. So what we shall do will be to start as follows. So please take note that x, if it is binomially distributed, would have f of x, the distribution of the random variable, to be n combination x, p raised to power x, q raised to power n minus x, where p is the probability of success and q is the probability of failure. Now please take note again that if x is binomially distributed, it means that x is discrete. It means that x is a discrete random variable. And again, if x is discrete, then the implication is that expectation of x will be summation from x equals 0 to n x times f of x. Okay, so noting these three things, we can now see that expectation of x will be, for this particular random variable x being binomially distributed, will be summation from x equals 0 to n x times what f of x is, in this case n combination x, e raised to power x, q raised to power n minus x. The next thing I'm going to do will be to continue in this manner. X equals 0 to n x. Now we would expand this. This is n combination x given as n factorial all over n minus x factorial x factorial, and this will be p raised to power x brought here, q raised to power n minus x. Now coming over here, we would continue as follows. Summation from x equals 0 to n, and this will be x times n combination n minus 1 factorial. Note what I have done there, expanding this just one step, and this will be n minus x retained factorial, and this will be x minus 1 expanded by one step again, and this I'm going to separate into p raised to power 1 times p raised to power x minus 1. Okay, by indices we've done nothing wrong here, because when you merge both of them in product, it will return this. Okay, it will return p raised to power x. Then coming over here, we will retain q raised to power n minus x. Remember, q is the probability of failure if p is the probability of success. Now this will give us summation no longer from x equals 0, because we are going to cancel x out. So this will be from x equals 1 to n. So I'm going to cancel x, okay, and I'll be left with n minus 1 factorial all over n minus x factorial x minus 1 factorial. P raised to power 1 is p, so I'm going to just put p times p raised to power x minus 1 q raised to power n minus x. Now please take note that n and p are both constants, so they can come out from the summation in product to give np outside, and this will be x equals 1 to n, and this will remain n minus 1 factorial all over n minus x factorial x minus 1 factorial, and this will be left with p raised to power x minus 1 q raised to power n minus x. Please take note that this, after the summation, is a new distribution. Okay, it is a distribution on its own, and as a rule, please take note that if f of x is a distribution, one rule is that it must be greater than 0, it must be positive. Another says that the summation of f of x must be equal to 1. So since n minus 1 factorial all over n minus x factorial times x minus 1 factorial times p raised to power x minus 1 q raised to power n minus x is a distribution, it means it satisfies this second condition, that the summation gives 1. And that means that we would end up having NP times 1, which is equal to NP, telling us that the expectation of x, if x is binomially distributed, will give you NP. And this solves the problem. It proves what we've been asked to do. Thank you very much for watching this video. Please like and share this video and endeavor to follow my page, John Hussein, on Facebook, or subscribe to my YouTube channel, GER Hub, on YouTube for more videos like this. Until some other time, stay blessed.